Okay, I'm just going to wait until I can test the sound, which should come up here. Testing, testing, 1, 2, 3. Okay, that sounds good. I'm going to move this to the other side. Cool. Okay, that should be good now. Today, we are going to take a look at Zen-C. But I'm just going to wait for a minute here. Maybe I'll even post something on online that I'm live. Where's the link? I don't even know how to get the link. That's funny. Oh, here we go. There's a share button. Oh, I just deleted my post while I was typing. Okay. Okay, cool. I'm calling it a C11 dialect. I don't know if that's accurate, but that's all good. Okay. So Zen-C released yesterday. And I had this page open. It was at 21 stars. Now it's at 843. That means it's probably gone on Hacker News and other websites. Hello, Alex. How you doing? Long time no see. So I wanted to use it on Windows, but currently doesn't support Windows. And there's some extensions for GCC and Clang that are used apparently that are not available in MSVC. I think that's what it says. Yeah. We'll have to wait for that eventually. I did my tutorial on programming Pong and Odin, then expanded it by adding some particle effects. Nice. That's cool. I'm glad you enjoyed it. Yeah, so this is a pretty interesting looking language. Let's just get into it here. So we've got, let's just look at the things that we can do in this language. There is type inference. So you could just type this and it's a compile time constant. I guess it's type inferred as a float, or I'm actually not sure. So this one's inferred as an int. This one doesn't say. It might be float or double or either, until maybe you use it with something and then it will promote, or I can't remember what the word is. And then there's explicit typing. That's cool. Used it before. It looks like Zig/Rust. It does look like Zig/Rust. I think more like Rust. I did try it a little bit yesterday. I just wanted to see if I could get it running. And it does run, and it compiles very quickly. So already it's, in my estimation, better. I mean, better on one dimension than those other languages. Yeah, there's some interesting things here, like null assignment. That's pretty cool. Coalescing null, safe navigation. Oh, I like that. The try operator. Hmm, that's pretty good. I will say, I think Zig's got a new backend now. It might be released now. I haven't kept up with the language, but most of their compile time was actually LLVM code generation, and it's the same with Odin. Rust, I don't know. I guess it's the borrow checker and whatever they're doing. But that's always going to be slow. Yeah. So we got fixed size arrays, tuples, pretty cool. Structs, standard, and struct initialization. That's nice. Bit fields. So the cool thing about this language is that C just works with it. I think Zig does the same thing actually, but it's not quite as similar. Rust uses LLVM as well. Yeah, I think most new languages seem to use LLVM. This language transpiles to C11 and then uses whatever C compiler you have in the config, which is GCC by default. So enums, which are tagged unions, so they can hold data. That's pretty cool. Useful. Lambdas and functions. Nice. And closures. Closures is something I didn't really know that I would want, but I think I do want them. They seem pretty useful. Yeah, I found not having closures when writing event systems, for example, is a little bit annoying. Some small things like not putting parentheses around if conditions. I mean, I know it really shouldn't matter, but since I use Odin all the time, I'm used to writing it like this. So when I go back to write C, I keep forgetting to put the parentheses and it's bugging me. Ternary operations, good, fine. Pattern matching is nice. So it's got range-based pattern matching as well. That's pretty good. So 2 or 3, 4 to 10. So that'll match 5, 6, 7, 8, 9, and 10 as well. Pretty good. Destructuring enums. Okay, yeah, that makes sense. So this is, in normal C, you would probably just have a type field, and you would have the type is circle, and then you would match on the type of the struct, and then do whatever. That's just sort of a nicer way of doing it, but either way is fine, I think. Loops, for in, yeah, iterators slash collections, for item in vector. Okay, but what is a vector? I have to figure out. I really hate this nomenclature, by the way, from Rust and C++ originally. Just because yeah, anyway, it doesn't matter. It's a dynamic array usually. While x is less than 10, okay, fine. Outer, oh, right. So there's labels. That's nice. Break label. I like that a lot. I wonder if you can yield a value. So I don't see it here, but maybe. Or maybe it'll be added. We'll see. I really like the idea of yielding a return value to a block. So a block is an expression. Then you can yield a return value to evaluate the expression, which is the block. So you could do like if x equals and then, sorry, x equals if and then some block and then yield a value and then else, and yield a value from the else block as well. And it will evaluate x to one of the two branches. God, execute else and return if condition is false. Execute else, return if condition is false. Okay. Unless, if not true. Unless is valid, return. Okay. I mean, yeah. Fine. Arithmetic, cool. Comparison, cool. That's fine. Indexing, yeah. Oh, we already looked at this. Oh. I put my mouse in the middle of my split keyboard and I might accidentally press buttons. Memory management with ergonomic aids. The defer is nice. I'll have to test it, but I'm sure it works probably just how Odin and Zig's work. Auto free, I did test this yesterday. So yeah, auto free is interesting. I don't know if I might use it in very select cases because you could just defer the free. So it's just preventing you from typing the next line with free types or defer free types. And then there's traits as well. So traits are from Rust. They might be from something else. I don't know. I only use Rust a little bit, so I'm not super knowledgeable about them, but I believe it's a way of adding capabilities to arbitrary data types and then signaling that that data type has that capability. So methods, that's nice. So this is how you implement a type, or the implementation of a type, and the other one's the definition of the type. Okay, drawable for circle. Yeah, this is a little bit alien to me right now, but that's all right. I like the use. It's similar to Odin's using. I'm not sure about if there's any other capabilities, because Odin's one has a few different places you can use it. But in this case, it would allow you to index the ID field directly from the player struct instead of going player.entity.id. So templates. Yeah. Okay, that's fine. Concurrency. This is interesting. I don't know that I would use built-in concurrency much except for really simple cases myself, because I would like to actually control everything about how the threads work. But this could be useful for some cases. I don't know yet. We'll see. Run code at compile time. I like this. I don't know what exactly the capabilities are here, but if you can just run any code at compile time, that's interesting. Could be good. I like embedding. This is nice. I use this a lot, so that's pretty cool. You can just access this as byte arrays. That's good. Plugins. So import compiler plugins to extend syntax. Yeah, this is interesting. There's a plugin for regex already included with the compiler. I'll have to check it out. And then preprocessor macros get passed through to C. That makes sense. Okay, there's some attributes. Must use. Okay, so yeah. If you don't use the return value, then this is going to give you a warning. Okay. Etc. etc. Alignment, that's good. Press unused variable warnings. Huh. And weak symbol linkage. I looked at this yesterday. That's kind of interesting. So you can define something, but then if you use this weak attribute, then it will get overwritten if it's defined again by another, translation unit. Place code in specific section. Oh, okay, that's cool. Function does not return, e.g. exit. Okay. Auto implement traits. Okay. Yeah, I'll have to brush up on traits and that kind of stuff. So inline assembly, that's cool. We are going to have to run this in WSL today because I'm running on Windows. But that's fine. I thought maybe we'll build a little virtual machine as a test. So we'll build like a tiny assembly language or something. That could be a fun test. So what have we got? Yeah, I am unreasonably tired. I injured myself at the gym and had to go to physio, and I can't sleep properly without my neck hurting. So I got myself another coffee. Hopefully that's good enough to get through the stream with a good amount of energy. But I feel like coffee sometimes doesn't give you energy, it just stops you from being able to sleep, which is not really the same thing. So maybe I should, I don't know. Is there something that gives you energy? Energy drinks, I suppose they're supposed to do that, right? Okay, compiler support, GCC, Clang. Oh, Zig is here. I don't think this was here yesterday. But yeah, that makes sense. I was thinking about that actually, that Zig would probably work, and it seems to. Cool, cool, cool. All right. So there's a few things I'm not clear on. There are some examples, so I just want to look at those real quick. Maybe I'll just clone the library and we'll look at it in the editor first. All right, so there we go. And I don't have any highlighting, but I think it's similar enough to Rust that Rust highlighting will work. So let's look at the showcase. I'll put set language Rust. Oh, I don't have a theme. Can I use a theme here? Apparently, my terminal doesn't support nice colors, so you guys are gonna have to deal with this. What are these, like default colors from the 70s or something? Okay. I don't know if that looks worse or better. Can I set it to none? No. That's not a valid. Nil? Null. No. Okay. That's fine. I don't know why I don't have colors. Is it because I'm in the... I don't know. It's fine. We'll sort it out later. I mean, I have colors, but I just don't have proper terminal colors. 256 colors. Or 24-bit, or whatever it is. Okay, so includes... Oh, no, there's no pound here. This isn't actually a pound, by the way. It's called a hash. But anyway, there's no hash. Everyone just says pound. Because a pound is a totally different symbol. It's the English sterling pound, sterling silver symbol. Point, struct, okay, we've got an event. So this is an enum with some types. So it's got some data here. Trait, button. Okay, so we've got a print line, which doesn't have parentheses. So it's more like a directive or something. Some kind of special syntax. Okay, interesting. Run op. So this is a function that takes a function and returns the result of the function. Oh yeah, it just runs the operation. Okay, yeah, that makes sense. So if we go down here, it's probably using it, right? Yeah. Lambdas, AB plus A plus B. So this is the function definition here, which is quite nice, actually. To pass that in directly there. So if we run this showcase, example showcase, I got to install this. Make install. Okay, there we go. Zen-C examples showcase. All right, so I've got a.out. There we go. So we've got generics and traits, enums and pattern matching. Okay, cool. So it works out of the box. Let's see. Okay, so there's a emit C option. Let's have a look at that. What do we get? Out.c, I think. So this is the generated code. Okay, so obviously there's going to be types and macros and stuff at the top. That makes sense. Now these are our types. Container button. Okay, so this was the enum, the sum type, right? Oh no, this was the generic. This is the generic generic container type. Okay, and then container with a button. Okay. Yeah, I got the events. Okay. Drawable vtable. Okay, so it makes a vtable. That makes sense. Yeah, this is very familiar. If you were watching the DirectX 11 stream, they have this vtable struct as well for all the DirectX 11 things in the C API. Container button get. Oh yeah, that was part of this, wasn't it? No? Yeah, get. There it is. Cool. Okay, so there's a lot of fprintf to std out. So that's what print line does, an fprintf to standard out. Okay. Did it say that somewhere in here? Print line. Nope. Not documented yet. Okay, that's fine. That's alright. It's only 1 day old. Give the man some time to cook. Cool. Oops, I'm looking at the wrong thing. Run op. That takes a Z closure T. What is that? Okay. So it's a struct with a function pointer and a context. Context is null, apparently. Okay, but this says underscore C. Where is that? Underscore C is op. Okay. Alright, well, generated code looks fine. It's not supposed to be like human readable, really. That's not really a big deal. It does include pthread by default, which is going to be a problem for Windows. Oh, I did see something just before. There's this freestanding which says no stdlib. But which stdlib are they talking about? So, oops, Felix, examples. So let's see, there's another example here. Okay. The quicksort. So here's a quicksort implementation. And it imports std.zc. So this is the Zen-C standard library, I guess. So if we try to compile that in freestanding, I'll say out emit C, sorry. Emit C, examples, and where was it? Algorithms, quicksort. Unused parameter R and print array, consider prefixing. Okay, so there's an error there. Let's see. I suppose I should actually just see if it works without emitting C first. Yeah, that looks like it works. Interesting. So, let's see. LAH. Okay, so it's 68 kilobytes freestanding. 68 kilobytes without free, normally. So, not sure what that's doing right now, but maybe it's not fully implemented. Let's have a look. Of course. What is this? Z prep. Okay, so this is the tokens and file config. Okay, not here. Oh, what am I doing? I can just search. Okay, here we go. Cogen. Freestanding preamble. It actually needs more work, but you know. Okay. So it includes standard library headers and sets some structs, sets a few function pointer. No, these are actually function definitions, but they're weak. So they'll be overwritten, I guess. And this is the standard hosted. Okay. And there's a REPL. Oh, I didn't see the REPL. Okay, I'm not sure what that is supposed to mean exactly. It's alright. Sort it out later. REPL. Okay. So funcs? No funcs. And fn add a int, b int, return int, return a plus b. Oh, okay. Apparently you're not supposed to just type that. I don't know how to use a REPL. I don't really use them. Are you supposed to just not do functions? Are you supposed to declare the name? Oops. Okay, my up doesn't work, but that could just be because my my setup isn't working properly. All right, no worries. Let's see. We got Zen-C here. We do. Okay, let's make a directory. We're going to call it mini VM or something. Okay, so we're going to make a virtual machine in this language. And I suppose the first thing we should do is define what instructions we're going to support. So I'm just going to make it a one file, I guess. And we can worry about other things later. So I'm going to do a split here. I'm going to open up the examples. Oops. I guess showcase. Because it has a bunch of things here. Alright, so I need enum, which is going to be opcode. And opcodes, I don't think I'm going to put data with them. I'll just write it in a straightforward way first, and then we can see if language features will help us make it nicer later. So what do we need? We need a, well, invalid. We need alt, and let's do move and add. Okay, that'll do. That should at least give us a program we can run. Okay, it's just going to be a simple register-based virtual machine. So let's see, what are we going to need? I guess I need a virtual machine. Some kind of struct. Is this how you write structs? This is how you create the definition? Yes. So we need program counter and so program counter, we need a register. Yeah, I guess I'll make that an array of U8s. Just make it an 8-bit 8-bit registers, that's fine. And then what else do we need? Maybe no, I think that should be I'm probably going to need more stuff as I make this. I just can't remember everything off the top of my head in order. So we need a way to initialize the VM. I keep almost writing Odin code, but that's not the right language. Oh, hang on. This has methods. So why don't we do the language way instead of writing functions directly, which is what I would usually do. The language wants us to use methods. Okay, so let's see. We got we can do init fn init, and we don't need to pass in anything, but we get self, which I like actually. It's interesting that it doesn't have a type, but I guess that is just nice because you already know the type from the implementation. Just better syntactically. Okay, so we have a self, and we just say self.pc equals 0, which should be 0 anyway, but let's just say we don't have initialized memory. And then since this is a slice, this is probably the wrong syntax, isn't it? Is there any arrays here? Yeah, so it's the C syntax, so I need to actually do it the other way. And let's just say there's 4 registers. That way, yeah, that'll just be an array that should be allocated when you allocate the struct. So say 4 reg in self.registers. But this is where I don't know how to refer to this by pointer. I'll see in the loop section here. Where was it? Okay. Doesn't actually say. Okay, let's look at the examples. Okay, not that one. Then see examples, and gonna look at, I guess I'll look at quicksort again, or binary search. Is it gonna do any pointer access for I in? Okay, no, not exactly. What about this one? Nope. Okay. That's fine. Hey Astra, how you doing? Just trying out Zen-C today. Building a little virtual machine here, just for fun. Guess we'll look at data structures. I don't know what's in here. Linked list. That's probably not going to have array-based lookups. Binary tree probably won't either. No. Well, I don't know if you can do that. So I'm just going to use index for I in 0 dot dot. Now, is this inclusive or exclusive? Don't know yet. So I'm going to do this. And then I'm going to run VM. How do you do this again? Oh, that's interesting. A shade of rust in C? Yeah, it does look like a shade of rust in C to me as well. Where is this? Alright, var explicit type. Okay, yeah. So VM is a VM, and it equals a 0 initialized virtual machine on the stack. And I'm just going to say vm.init and just see if that works. Oh, I need to open another thing here. WSL. Is it just WSL? Yeah, nice. Wait, what? Oh, this is the wrong directory. Different fun directory. Okay, so we're going to do ZC main.ZC, and it says an error already. Unexpected token in parse primary. Am I not supposed to declare the value? var explicit float equals 1.0. Okay. Well, I'm not sure if I'm supposed to do something like this instead. No. How does he create new types? I mean, without using a new function, which allocates. Well, that allocates. Showcase. Is there anything in here? Is there anything? Oh, here we go. You can just use the struct literal. Okay. So, like this. Okay. I think that'll work. Right, there we go. And we got a.out 0, 1, 2, 3. Okay, so this is the same as this in Odin. You just don't need the less than sign, I guess. Cool. Is there dot dot? So there's a range. Doesn't say if there's like a range that's equal to. Not yet. Alright, no worries. Cool. Okay, so we know that it's 0 to 4, and then we can just say, you know, self dot registers equals I equals 0. That's fine. So even though this is should already be 0 initialized, I don't know if it is. Gonna just do it anyway. Good. I just realized something. That worked without a semicolon on the end, didn't it? Look at this. So there's no semicolon on the end of this line. But it still compiles. Interesting. But if I remove this semicolon, is it going to break? No. Wait, do we not need semicolons? Oh, yes. I don't think it says anywhere that semicolons are optional. No, and all the examples have semicolons. Is that supported behavior? I'm not sure. I'm just going to add them for now, but it would be nice if we didn't need them. What's wrong with this? Bit fields only allow packing struct members into specific bit widths. Int x3 uses only 3 bits. That's nice. What does that have to do with anything? Oh, is this a type? Actually? Stuffs device interlaces with a... Alright. Yeah, I'm not using a Duff's device as far as I know in the actual code, but it looks like I might have generated something with a Duff's device. Let's just have a look here at the types again. I want to make sure I'm using the right type name. So U8, yep, it is a capital U. Oh, or you can do lowercase u. All right. Cool. Or byte. I actually do prefer byte. Yeah, either one's fine. I prefer byte when dealing with data because it's not like, you know, when you're streaming in data, you're not really thinking about it as a list of numbers. Anyway, that doesn't really matter. But something about this is not, it's not happy. It doesn't like it. Yeah, okay, I thought so. It was this. It doesn't like this initialization without any fields set. Can I do this classic C initialization? I mean, I think I already tried it, but No, it doesn't like that. Did you mean VM? So these errors are from... I think these errors are from GCC, not from Zen. Because the ones from Zen say Zen in front of them. What if I do this? Yeah, no, it doesn't like that either. Alright, so for now, I'm just going to set this field to 0. And that'll do. Oh, and I lost what I did up here, which was self.registers I equals 0. Okay, cool. Now, set up our registers, and we've initialized our VM, and we're going to add some bytecode. So we're going to say... There was something in here about a vector, right? So vector is in the standard library. I'm just going to use the standard library of this language here to make a vector of bytes, which is going to be our bytecode. So we're going to need to turn... Actually, we don't need to do the assembly side. I guess we don't need to parse the assembly right now. We can just go straight into intermediate representation and then turn that into bytecode. So we can say something like add instruction. Wait, hang on, I'm not going to do it like that. I will figure that out later. That's fine. But we want to just write a program that looks like this. Move into R0, 1, 2, 3. Move into R1, 100. Add R0, R1, and then halt. And then we should be able to see the value R0 is equal to 223, basically. Rather than C and Rust, it looks more like Odin and Rust. Really? It looks like Odin to you? I can see a little bit of that, like the defer keyword, the yeah, really just defer actually. What do you think is like Odin, no way guy? Okay, so that's going to be our program, which means we need some bytecode. I'm just going to put bytecode, and it's going to be yeah, U32 will have 32-bit fixed size instruction set. And I'll just say we have 8 instruction slots for now, so we don't have to deal with memory management yet. Okay. That's cool. So we want to assemble a language, assemble something into bytecode. The thing that we want to assemble is going to be based on instructions. The instructions are going to be some kind of instruction. So we'll do something like opcode, which can just be U8, or it could be, no, it could be an opcode, not U8. Opcode, and then let's map this out quickly. So we have 32 bits, right? So we can have opcode. For now, we'll just do 8, and then what do you usually call these? Operand 1? No, there's like another name that I usually use. Anyway, value 1 would be 8, value 2, and we don't even have a third value yet, so we'll just say this is unused. For now. Okay, so something like this. In fact, we don't even need to use that much space. Like, we could use, whatever. I'm not going to get too complicated with this, but we could compress this quite a lot. So I'm just going to use it. Really dumb, straightforward solution, because all we're doing is building this tiny, tiny VM right now. But if you wanted to build something with much smaller bytecode, you could easily do that. And I'm not going to do that right now. Maybe on a second pass. Okay, so we got value 1, which is going to be U8, value 2, which is going to be U8, and then nothing. That's it. So this would be, oh yeah, source, destination, source. Yeah. Of course, that's what I'm usually talking about. All right. So we're going to do something called destructive operations with this virtual machine, which means if you look at the assembly code, when you move, when you add these two values, R0 and R1, the result actually overrides the value in R0. So if you wanted to keep the value of R0, you would have to do like move R2, the value that's in R0, and then you could do this, and then you'd have the value stored in R2 that you could use again. Yep, that should be fine. So we have instruction. Now let's write some instructions. We'll just write a little array here of basically these instructions. So we're going to say instructions is, that's not the right, var instructions, and then we got, was it 8 I said? Yeah. 8 instructions. And we're only going to use 4. So this will be opcode is move. Yep. Okay, and we don't have registers yet, so I'm going to make a type here. Register R0, 1, oops, 1, 2, 3. Just so we have a typed value. I prefer that rather than just using a number, because you might get, depending on how you write your VM, you might get confused and put number values into the register field or into the bytecode. And although it just looks like a number, you just have a little bit more type safety around it. So destination is R0 and value is actually 1, 2, 3. Oh yeah. Okay, so we need an immediate value so that we can use this. So an immediate value is actually a number that's stored directly in the bytecode, whereas this source would be basically like a pointer to a register or an index to a register. So instead of getting the value from the register, we're going to get the value from the immediately from the bytecode. So we can store that number 1, 2, 3 in the bytecode, store the destination, but we don't need a source because this is a immediate to register move, which means actually we're going to need to do a little bit of something, a little bit of bit pack in here. So we're going to have an opcode and a mode. Actually, you know what? I'm not going to do that. I'm just going to do move immediate and move register, and then add register and add immediate. So I'll just have more opcodes instead of adding a bit packed mode here for this toy example that doesn't matter. So this is a move immediate, and we're going to have a move immediate and then another move immediate, which is going to be into R1, the value 100. Then add register. Destination is R0 and source is R1, but I don't know how to access these enums. So let's have a look at these docs here. Where are enums? Okay. So would I just do register.r1, or is it just called R0? Let's have a look. What happens? Oh, sc.zc is not found. Okay. Well, I won't import that yet then. That's fine. I'll probably have to add that somewhere. Unexpected token. Okay. So this is the wrong syntax. Oh yeah, it wants square brackets. Okay. Square brackets around an array. You know, I almost did that in my language that I haven't actually made yet, but I was thinking of making. Oh, okay. Is this comment type not supported? Maybe. But that's definitely not the right comment type. All right. So R1 is not declared, and also register expected expression before register. Move immediate is not. Yeah. So none of this is working yet. Okay. Let's see. Event clear. Okay. So it's double colon. Double colon. Okay. Yeah. All right. So it's register R1 like this, I think. And this is opcode. I will say I find that to be a little bit not sure what the word is. I like Odin's one where you can actually just omit this type because the type is already known by the compiler because the type of this field is known, and you can just put dot and then whatever the enum is. But hey, that's fine. If this works, that's good. Okay, not quite. Let me just clear this. Okay. Opcode move immediate is incompatible. Anonymous. Okay. Maybe this syntax is required if there's data, because this is all data enums, right? Some types with data. Is there another enum here? No. What about in this one? I don't think so. This one? Nope. This one? Nope. Okay. Guess I need a little bit more guidance around what types, like the syntax around enums. I think that would be useful. Non-null pointer human. You like the idea of this language stripped down Rust without ever adhering to the borrow checker religiously. I like it as well. Actually did enjoy Rust, kind of, except the compile times are really slow and the borrow checker is really annoying. So those are like the main things that, well, yeah, I guess I just liked the features that I had, and this language seems to have a few of those features that I like, or a bunch of them. All right, so how do I? Let's make this a bit simpler. Oh yeah, I can't do that. Okay, I'm just gonna select the hash. All right, so I'm just gonna say var my reg equals register dot r0. Have I tried Jai? I haven't tried Jai. I've heard really good things about it. I'm looking forward to trying it. I'm gonna wait for release. I thought about applying for the beta, but well, there's a couple of things, a couple of reasons that I didn't. One is, you know, I want to make content, and then if you're not in the beta, it wouldn't really be relevant, but I guess it could be interesting. Another is, I don't really know what I would say to John, Jonathan, I should say. I don't know what I would say to Jonathan Blow to convince him to let me try the language. And I thought about that for a while and just couldn't come up with anything that seemed reasonable. I think he's done a lot for the game development community, at least in my opinion, and for myself as well. And also thinking about the art of games and, well, yeah, I don't really want to get into that right now. There's a lot that I'm not sure how to say. It's so pleasant to write, Jai, for you at least. Well, that's great. I'm glad to hear that. I'm looking forward to trying it for sure. Expected expression before register. Okay. How do I get this? Okay, that's not how. Is the compiler still broken? I mean, it might be. I'm not sure. Is there anyone talking about enums in the issues? Not is enum. Enum. Grammar railroad diagram. Oh. You think it's double colon? Whoops. Double colon. But then this says, right, it's looking for unused variable. Oh, it's just unused variable? Okay. That's fine. Okay. Yeah, I am quite tired. Okay, yeah, I gotta do this. Okay. I think you might need a semicolon. That wasn't the problem. What's wrong with this? Okay, I'm not sure what the problem with this is. Let's have a look. I'm just gonna go back to basics. Hello world. Putting the actual compiler back in error seems a really nightmare. Yeah, I get what you mean. Okay. Did you guys see that? That's not deterministic, right? Bit fields allow packing struct members. And this one doesn't say that error. Doesn't say it, doesn't say it, doesn't say it. This one does say it. There's some non-determinism. Okay, that's not good. This isn't an error, but why is it telling me this? It thinks something is going on here. Right? Okay. Cool. So let's see. This compilation just fails, and it fails every time. Does it include any runtimes? I don't know, actually. It does have a freestanding option, but yeah, I'm not sure. Oh, there's a run option. I should probably just use that. Okay, so this doesn't like this. I'm not sure why. It just can't figure out how to print this or something. What if I give this a type? Oh, data. But I don't want to give it data. That's not the point of it. I don't think this is going to help me. This is just some AI generated stuff, grammar. Well, actually, maybe it would help. Let's see. Where's the enum? Yeah, enum definition. Yeah, enum definition. Enum identifier variant. Enum variant. Okay. Yeah, I don't know. It's been a long time since I read a grammar like that, so maybe that's not that useful for me. I'm going to look at the search. I want something in examples. I guess I could just look at the code gen, but okay, like this one. Yeah, they do use the double colon, right? For quit. Yeah. And oh, hang on a second. That would be a bit of a weird way to do it if it's not, if it has no data. I don't know what I can do with my register. I guess I can, what did it say? If it's unused, consider doing something. Okay, so this is working. Is this working? Apparently. Okay, so here's what I'm going to do. I'm going to put in here, that's the wrong, I can't do that. I'm going to have to use GDB or something. Let's have a look. We've got, oh, that's weird. It like deleted the file. Said main.zc rather. Oh, is there a debug way to output debug symbols? G, yeah. Okay, here we go. This is just a warning, that's fine. Now I've got debug symbols. I can run do I have GDB? No. What is this? Arch Linux? Okay. I don't want to run. I want to start. No. Step. I can't remember all the keys. Where am I? Print. End of the file was already reached. Okay. Well, that's not great. Well, because I just declared something and then it doesn't do anything. Is it step? I'm pretty sure it's step. Okay, but I'm not seeing like the line that's running. Okay, hang on a second. Uh, 24K. I can't remember how to check if there's actually debug symbols in here. Display debug information. Yeah, -G. Okay. So there is debug information. All right, cool. That's nice. Don't know why I can't see it though. I'm going to do Zen-C -G-emit C and main. Now I've got an out.c. Now I'm going to do this. Now it is 87 kilobytes. That seems like it has more debug info. And probably didn't compile out some stuff, so that might work now. Let's see, start. No, there we go. That's what I wanted to see. Continue. No, I shouldn't have continued. Whoops. Step. Okay. Now we've done this line. No, we're not. We're about to do this line. So step, and then I'm going to print out my. Yeah. Okay. So it's a pointer. Oh, it's a void pointer. Void pointer to register 0. Huh. This is a function. Oh. And it returns a register with a tag, register R0 tag, which is an enum that starts at 0. Okay. Right. So that's good. That seems like it's working then. Okay. So if I call, I shouldn't have done register 0 because now I'm just going to get 0, right? Wait, can I call this? Yeah. Okay, nice. Okay, that's working. Just to double check that though, I'm going to go with register 1 instead of R0. Hang on, I need to compile it. This, continue, no, start, step, step. Okay, that's good. Alright, alright, so we got the right tag, so that should be working. Okay, great. So we've determined that this is the correct syntax, which is good. The Zen vector implementation, looking at the Zen vector implementation, you're surprised they resort to exiting the program when undefined behavior happens, instead of using optional, which the language supports. Yeah, well, I mean, I'm sure a lot of this stuff is going to change over time because it's just 1 day old, right? I don't know how long he's been working on it. So this should work, I believe. Does not. Doesn't work because why? Okay, I'm going to reduce the scope of this. It's going to have one instruction. Oops. Okay, one instruction. It's this, and I just put the semicolon in the end there. I don't know if that's required. We got opcode, destination, and a value. Let's have a look at that. So, incompatible types when initializing an anonymous enum using type opcode, which is a void pointer. Okay. So initialization of unsigned character from void pointer makes an integer from pointer without a cast. And instruction has no member val. Okay, that's probably a problem. I'm just gonna make this in. Yeah, I'll just make it U8. So that's that problem solved. Now these ones, move immediate. I didn't like that. Do I have to call it and then get the... That doesn't make sense. That shouldn't be a thing. Let's see. Okay, so that... This is silence the error for this opcode by calling it as a function. Because then I guess get back struct. This one makes integer from pointer without a cast. Oh, I didn't put a type. I think this is supposed to be type U8. That could be the problem. No. Right, but it's not supposed to be type U8. It's supposed to be type register. Oh yeah, I'm stupid. I'm not reading the error properly. So I need to cast this to a U8. Because the destination is a U8, not a register. Aggregate value where an integer was expected. Oh yeah, because an instruction... Wait, what? What's wrong with this? Using an aggregate value where an integer was expected. Why was an integer expected? So this is the same syntax, right? I'm not going crazy here. And I have defined an instruction struct. There's no implementation. There shouldn't have to be one, right? Like this? No. Also, I just realized these can be register because they are supposed to be register. And then I won't have to cast it. And then I wouldn't have got that error. So that's nice. Oh, and now it works. Wait, what? That's strange. But was it just user error the whole time? I don't understand how that tracks. But anyway. Alright, so I've got an instruction. I'm not going to sweat it right now. And just put that in there. So we should be able to... So you just don't have to put in source for the instruction struct. Well, if you're not using it, you shouldn't have to. You shouldn't have to fill out every value. If it compiles to C, it should... I think it'll zero initialize the unused fields if you initialize one of them with a value, which is why if you do it in C, if you do something like my type empty equals 0 like this is initializing the first field to 0, which then means one of the fields is initialized and the rest get initialized to 0. I'm pretty sure that's how it works. Okay, so it's a little bit funky having to call these as if they are functions, but I guess they are, but they don't have data. And it is necessary, right? Yes, it is necessary. Okay. But now we have some instructions. That's good. Now we want to encode the instructions. So I don't have an encoder, so I'm just going to make an encode function. We're going to encode instructions. Oops, instructions. And we're going to get back bytecode. I don't know why I did that. Instruction array. Actually, this will be interesting. Are there slices? I didn't see anything about slices. Let's have a look in here. Length. So this has a length, but that's the vector type. This is their implementation of a vector. And we've got quicksort. This is also using a vector. Binary tree. Yeah, I didn't think there would be a length lookup in here. That makes sense. Okay, I'm not sure. Let's see. Okay, nothing about length. All right. Well, I guess we'll just try. Well, we'll just pass in 8 instructions for now, and I'll worry about the rest later. And we're gonna return. Well. Oh, this thing's probably gonna allocate. We're gonna return a U32 array. Is that a valid type? Not sure. Could just be pointer, right? So U32 pointer. But then we don't know how long it is. Oh, we do know how long it is because the bytecode length will be the same length as the instruction length because it's a fixed size instruction architecture. So yeah, we could probably just send back a pointer to a U32. I'm not going to worry about lifetimes right now. So we say bytecode is alloc, and we want to allocate. Is there another alloc example here? Wait, can I even use alloc if I don't include this std.zc that didn't work for me? Maybe. 8 times U30 size of 32. Is that even correct? I don't know. Let's see. And we're going to return bytecode. Does this compile? I'm just going to do ZC. You know what? I will do this actually. Okay, so apparently that's not. We don't like that. So that alloc, that must be a type. This has to be a type, I'm guessing. Since that's not a type, let's have a look in here. Oh, here we go. It's just malloc. All right. That'll do for now. So just allocate that. That should be okay. What's wrong with this? Expected. I can't pass it by value, I suppose. This probably has to be a pointer. And then length. Hmm. Um, U32 is undeclared. Did you mean capital U32? Oh, that's strange. Because you can use lowercase u8. Hmm. Wait, but this is U32 here. What? So it doesn't work down there, but it does work up here. So if we look at the generated code, it's probably going to explain that. So I'm going to have a look at out.c, look for U32. Oh, here it is. And the small case, lowercase? No. If the lowercase one didn't get generated, then how does this know that it's a U32? Interesting. And also, what is this malloc doing? Size of what? Size of void pointer. Oh, that's a different malloc, I think. Oh, yeah, let's make vector. Oh, so did this not get emitted? Where is it? Encode? No, there's no encode function. That's odd. Okay. Alright, so it did print the pointer just now. Did you mean return bytecode? Undefined variable bytecode. Did you mean bytecode? Yes? I suppose I did. Okay, function designators convert to pointers automatically. Foo and star foo all resolve to the same address. Function designators. Okay. That's nice to know. I'm pretty sure that's the right syntax for this language. Hmm. Where was showcase? Yeah, there it is. Okay, so none of these functions take pointers. Pretty sure quicksort did, right? Yeah. Okay. So instruction pointer, that's what I'm passing in. An instruction pointer. Okay, so if I change all of these to uppercase, all of the U32s rather, I am still getting a value back, so it is allocating this memory correctly. That looks like a valid pointer. Start, no, step. Okay, so we're going to set up the registers. Okay, set up the instructions. What? Okay. I must be in this scope here. Yep. All right, good. All right, so got the instructions. That's a little bit hard to read, but let's see. Move immediate into R0. The value 1, 2, 3. Cool. That's fine. Where are we? So we're here. We want to look at the bytecode. So I'm just going to say next instead of step. And the bytecode is there. And I want to look at the value. It's 0 because, well, we would have allocated memory and got zeros. Not always, because we didn't use calloc. Okay. Looks like it's working. So we've allocated space. For some reason, it didn't like the lowercase u32 down there. So what I'm going to do is just use the uppercase types. For now. And what are we going to do? So we're encoding instructions. So now we have to say for instruction in... Oh, we didn't actually pass an array. So how does it know how many things in the array? Guess we just do a normal range for I in 0 dot dot len. Instruction pointer. Oh, I don't have to do that. That's nice. I think I don't have to. Instructions I. Okay. Now we're going to match on the instruction dot op code. I think it's match. There we go. Yeah. Okay, so we might have wanted to structure this differently. I'm just not used to writing in this style. This could also just be a switch. But I'll use the new feature, even though I think it'll be not as, idiomatic Zen-C. So let me get a... What are the opcodes? Invalid, all of these. Okay. Is that right? Okay, that's fine. I think that's correct. I don't know exactly. So why don't we just do this? I'm going to highlight the names of these. I'm going to print the name here. Is that even the right syntax? Expected variable name in pattern. Okay. Oh, right. Wait a second. I think I misunderstood this. Shape. Okay. There's also different syntax for everything. Like this one is different. But anyway, the problem. Expected variable name in syntax. Well, actually, instead of matching first, I can't comment. I'm going to change the language to Rust, and you're going to have to deal with the horrible colors. I'm going to print the instance. Yeah. Oh, we can't do that. The instruction. It doesn't like that. Okay, can I print the opcode? Doesn't like that either. What if I cast it to a U8? Okay, it doesn't like that. Aggregate value used where an integer was expected. What? How is uint8 an aggregate value? Oh, opcode is. Is that what it's saying? Do I have to call that? Right, implicit declaration of instruction opcode. Huh. Let me look at these again. I'm obviously not understanding the use case for these enums very well. No. Okay. What would have enums? These don't, I don't think. Stack probably wouldn't. Nope. Tools. Mini grep. This might have enums. It doesn't. Okay. So dramatic. You guess Odin is over. So funny. No, I still use Odin every day. Not like you have to choose one thing. File time generated Fibonacci sequence. Yeah, okay. By the way, have you seen the movie Gattaca? I think that's a really cool movie. Your name just reminded me of that. Mm. Yeah, nice. I just got water on my trackball. So that's not good. 1 second. Okay. Yeah. I don't know. Maybe one of you guys is understanding these enums more than me if you've been programming in Rust or something. It's been a while since you've used Odin. Is it really stable? It is stable. So like 99% stable. Is the documentation good? It's good. Um, there's a worm encrypted in triplets in your channels. Oh, a word encrypted in triplets in your channel's name. Okay, interesting. That's cool. Yeah, documentation on Odin is really good now. I'll just show you real quick. Odin language. There it is. Docs. So this page is the most useful, which is the overview. Well, I think it's the most useful for just like getting started with the language. It's got like everything you want to know about how the syntax works and language features, etc. And then really useful advanced stuff as well at the end here, like attributes, which for a lot of programs you're not going to need, but sometimes this stuff can be pretty useful. Directives for the compiler as well. The one that I use the most is, where is it? Um, it is, wait, is it load? Yeah, load. So load allows you to embed data like from a file directly into your binary at compile time, and then provides a variable that you can use it with, which is really cool. I use it all the time for embedding stuff. And yeah, it's just really nice. But other than this, there's also the package list here. So this is all the standard library stuff. So if you want to look at like, you know, What is useful to look at? Slice, maybe? Where's slice? Here we go. You can see all the procedures related to slice. So there's like comparisons and concatenation, checking if things are in the slice, filtering, etc. I think strings is pretty useful as well. I use that a lot. Strings in the standard library. There's tons of procedures here. String builders are pretty cool. Yeah. Anyway, I'll check it out if you haven't checked it out in a while. Back to the problem at hand. Apparently it doesn't like this. So what I'm going to do is I'm just going to say var x equals inst and that'll do. I don't know why I'm doing that actually. Can I do debug break? That should work, I think, with this compiler. Cool. Yeah. All right, here we go. So have a look. We're here. We should have inst. Does this new Zen-C thing can do vector math or overloading operators? Don't think you can do operator overloading. I don't think it does vector math either. I do like vector math a lot, so I'm not 100% sure. But that would be a really useful feature for game devs for sure. So apparently this is not in the current scope. So let's just have a look. Step. There we go. All right. So we got an instruction. It's got the tag. It's got the destination. It's got the value, which is 100. Oh, so we're on the next one. I forgot about that. So sometimes when you call this, debug break, or you put a breakpoint at the end of the scope, it'll break, outside the scope because there's nothing here to break on, no next instruction. So it's actually going to break at the next loop, which is what I just did. Just good to know that this doesn't count. So you'd have to put something here, like this. If that was there, then it would break on this line. Anyway, so I got the value, etc. That's fine. Okay. But how do I match on it? Let's just see what happens. Match inst.upcode. If I do, this is the default, right? There's a test for matching. Maybe I'll look at the tests. Yes, tests slash... What? Where are the tests? Are they in the std? No. Are they in source? Apparently not. Hang on a second. Let's just get out of here. Go into the thing itself. I'm just going to open Helix here. Have a look for tests. There are not tests. At least they're not called tests. If I run that command, where was it? at the bottom here. Run test slash. The test suite is your best friend. I need to make the tests. Apparently. Okay. All tests pass because there are 0. Well, that makes sense. I think maybe this is just an example of how you could write tests for your own code rather than tests for the actual compiler or transpiler, whatever you want to call it. All right. Well, that's okay. Okay, so we've got the default case here. So all we're going to do is we're going to copy this, print something, plus new line. Okay, what happens if I run this? Yeah. That's not the right thing to call, and print is not something, apparently. Okay. So we did get something. What we got, though... Oops. Perhaps unknown. Now, if I use this print line, it's included with Zen-C, and I try to print... It's not going to work, is it? Expected string literal... After print... What? Yeah, it's not going to work. Okay. What about dot opcode? No. Generic selector is not compatible with any association. Look, I don't know C11, so I don't know how this works. So I can't even debug it myself right now without more effort than I'm willing to put in. Also, this print doesn't seem to exist, but it could be because I haven't imported std.zc, which I don't even know where that is. There it is. So I'm going to copy that. I'm just going to make sure that's actually the file that we want. Oh, and I also copy the... Okay, sure. So I'm going to copy std to minivm and also std.zc. Alright, so hopefully that will give us a better experience. But at least we can include the standard library, which includes what? So we got file... What is this? FS. File system, but also IO. Okay, yeah, okay. There's a map included, alright. There's a memory which has alloc, zalloc, and... Oh, 0 alloc. And alloc n, okay. So alloc and zalloc only return a 1 of something. Interesting choice. Network set vec core based on path time option result string. Oh, so it's got a custom string type. Okay, that's good. I would have done that too. Threads. Okay, we don't need this. We just need to figure out how enums work, because apparently I can't print anything. I can see in the GDB output that it looks like we're getting the right value. But, oops, not destructuring. I guess it is destructuring. Destructuring an enum. So it should just be like this. Invalid, then that should work. Oops, not there. Do we need commas? Yes, we need commas. So we've got move immediate. Maybe I shouldn't have deleted that. Okay. Move immediate, and we've got what's the other thing? Whatever, that's fine. I'll leave invalid actually. So invalid and move immediate. So all I need to do is print that, but that's not gonna work because I don't know. We're not allowed to print this with this function or something. All right, that's fine. We'll just use classic printf. All right, so apparently, okay. Do you just get random tips? Is that what this is? Do you just get random tips? Like, because I'm not even using a map. I will comment this out since we're not using it. So we got invalid only, which is odd. So move immediate. I'm pretty sure we had a move immediate, right? Yeah. 2 move immediates and an add register. Okay, I'm just going to print the length. No, I don't need to print the length. I can see there's 8 outputs. Do I need to look this up by pointer? I shouldn't have to. Can I just say if inst.opcode is equal to opcode move immediate, then print this and also a new line? Apparently I can't do that. What's the declaration of equals? Right, because these are not comparable types. So if I cast it to a U8, aggregate value was used. Apparently I can't do that. Alright, I might just give up on using enums for now. Strange as that might seem. And I could just define these values. I do want to use the language though, not just get around it with writing hacked C code. Yeah, I don't like the idea of that. Okay, I'll try a little bit longer to get these enums to work. Alright, so we can't compare them directly because opcode move immediate is Code move immediate function returns an opcode struct with a tag, right? So how do we get the tag out of the enum without using match? Is it even possible? Right, because it doesn't seem to be matching. So we match on the opcode, we get invalid every time. Am I supposed to actually define these like, you know, you might do enum operation, and then invalid has nothing, but move immediate has a destination and a source and a value, right? And then move register as a destination and a source. And then the same for add. And then halt has nothing. So like this, is this how you're supposed to do it? But then it doesn't have a type. How do we do it? Oh no, this is supposed to be a type. So this would be register. And then, oops. This would be U8. And then this would be register like this. Okay, and then we could make the instruction not even an instruction. We wouldn't need this anymore. So we would have, I just called it operation, but this would be our instruction, I guess. So we've condensed these into a sum type, right? I think this is how the language wants us to write it. It's just not how I'm used to writing things. So then we get well, it's pretty much the same, I think, except this wouldn't have an opcode. It would just have, I have no idea how to instantiate it. Like this. So we'd have instruction move immediate, and then it would take in register R0 and 1, 2, 3. Let's just use one instruction now. Okay, I am missing something. Missing a parentheses, but it doesn't say the line. Okay, let's just have a look. These are opening and closing. All right. What am I missing? I'm missing a parentheses, but where am I missing a parentheses? That looks fine. Is it here? Not like that? Nope, that's fine. Oh, wait. Yeah, that's good. Good. I'm quite sure that's good. Okay. I'm going to run it again, even though that's not going to change anything. Okay, so now, let's see. Comment out this. That's not where it is. Gotta have something to do with what we just changed, right? If I just comment out that. Well, that's not going to work now. Missing closing, expected closing parentheses, but where? What if I get rid of this stuff? Is it going to give me a better error? No. I guess I could compile the Zen-C compiler in debug mode and then run that in the debugger to see where this error is coming from. Okay, so here's what I'm going to do. I'm just going to comment out these. Comment out these. Ah, well that's wrong. There's no opcode anyway. But anyway. And this. Okay. Now I'm going to uncomment these. I really hate debugging like this. It's the worst way to debug. Alright, so something it doesn't like about these. Is it that there's no register type? Because I deleted it. Is that the problem? Probably a problem. R1, R2, R3. Okay, that's not the problem. Can there only be one data type in an enum? That could be why it's expecting a parentheses. Which means I could have like a struct instruction data, and then this could be what we had before basically, which was source, register, destination, value, U8. Oops. Is that, well, incomplete type? What do you mean incomplete type? Move immediate has incomplete type. All right. How is that the case? Register exists. U8s exist. I mean, if I wanted to be use less types. Hello. Okay. I can't type in this window anymore. Something has gone wrong. No. What are we making again? VM. So, Zen-C main.Zen-C. Apparently it works now. So it doesn't like the register being... What? What's wrong with these? Oh, you have to have a value? I don't know. Maybe I need to make these a U8. Is that the problem? No. It just doesn't like those. I don't know what's wrong with that. R0, R1, R2, R3. Okay. I'm just going to leave that for now. We'll just use U8s, which is what they're going to be anyway. But now we don't get any type safety on it. But whatever, that's fine. So I think we're using some types the way that the language wants us to now. So if we add this, nothing changed. Oh, that's not good. Oh, because we didn't add any instructions. There we go. Undefined variable bytecode. Yeah, that's not a problem. Register R0. Yeah, this isn't a thing anymore. So we're just going to have to pass in 0. But this is a struct, so we... Wait, no, it's not a struct. But this is a struct. So we want to do destination is 0 and value is 1, 2, 3. That almost worked. I think we need the type, which is instruction data. Okay. Bloody hell. Okay, let's see. Compile with debug symbols. Run in GDB. Oops. A.out. I can just type run. I think we're going to get to the right spot. No, apparently we're not. Wait a second. The end of the file was reached. What? That didn't get to this at all? I guess because the match... No, I don't know why. Okay. Oh, well, I remember. I had to do it differently, didn't I? To get the actual debug symbols, I had to do... what is it? Emit C, and then gdb-g3, out.c, and then... Huh? Was it not G3 and GDB? No, not GDB, sorry, GCC. Run, no. Okay, there we go. So we're around here, we got some instruction, which is move immediate. But when we step... Actually, let's look at the compiled C code. I'm looking for int3. Oh, didn't do it. Good. Why can't I see the int3 in here? Reload? Maybe it was not reloaded. Yeah, okay. Alright, so I got the instructions. So what does this say exactly? It says instruction M0 is instruction. If 1, print invalid. Else if 1... Wait. Okay, I think I'm seeing a problem here. Huh. That's weird because when you look at the example code, it works. So if we look at the showcase, right? Where was it? Showcase. It's got a match. Where is it? Here. Oh, so maybe I have to use this exact syntax, which would make sense. And this is instruction. Okay, yeah, that looks like it's going to work now. Let's reload this. All right, so the problem was I was using the wrong syntax. Why was I using that syntax? I think I misunderstood this. Yeah, I misunderstood these to be enum entries into some kind of shape enum. And So the syntax was wrong, and it wasn't erroring, it was just giving me always the first result. Which means probably I could have written the code not like this, and how I had it before. Yeah, okay, I'm gonna do it the way I had it before. Let's see, not like this, not like that. Okay, here we go again. Now, whoops, somehow I just did something in the start menu. Whoops. Right. Yeah, let's get rid of this. Okay, move immediate, add register, invalid. Okay, great. That's what we wanted. Man, that was a mission, and it was just syntax. Confusing. That was confusing for me. I don't know if you guys found that confusing, if you're even watching. But, yeah. We got it sorted now. So now halt. Oops. Alright, but I didn't actually add a halt, so I need to do that. And it doesn't need any other parameters. Full, start, no, run, rather. Okay, cool. Alright, so we've got move immediate, add register, halt. Finally! Okay, finally we can actually write the virtual machine. So these are the instructions. Now we just write the encoder, which is just going to be this function. So we're just going to encode these into U32 values. So I'm going to say add, oh wait, hang on, I should use the language feature, shouldn't I? So we have a encoder, because everything needs to be a thing that does things. It can't just be a procedure. And then the procedure can have an encode. No, this is lame actually. We really don't need this. I'm not going to do it. I'm just going to say encode source is a function that takes in the value, which is going to be an i32 pointer. Actually, an i32, and it returns an i32. So if we look at the structure we've got here, we've got an opcode. Actually, let's do opcode first. The opcode. So we're going to encode the opcode into this 32 bits. The way that we do that is we get the opcode, which is actually a U8, I suppose. Wait, no. We have types now, don't we? Yay. And we say return. Oh, we also need to pass in the current instruction, which is an no, it shouldn't be i32. It should be u32. Because we need that top bit for the opcode. And it serves no value being negative anyway. So we're going to return inst and opcode. I don't need to do anything to the opcode, but I'm going to do it anyway. No, I don't need to. I just need to shift it up. I'll cast it first to a U32, just in case it's some other type. Shift it up to the start, which is going to be 24 bits. And that should be it. So that's pretty simple, right? I think that's correct. No, I don't want and. I want or. Cool. So return inst, and then this one, the source. Then we'll do destination. We'll just do it in order. I'm not going to copy, because every time I copy, I mess up stuff. I forget to like replace one thing. 32 turn inst or. We're gonna turn the source. I don't know if this is gonna work. If you could just cast the value of this, maybe. We'll see. I might need to call it like a function or something. And this is going to be 16. And then 8 for the destination. Okay, I think this I can copy. Right, it's exactly the same. Right, yeah. And finally, the value, which is U8. That should be fine. Yeah, that should be fine. Cool. Except this has to be value, not destination. All right. So now we have to do the encoding, right? So if we have a register immediate to register encoding, then we're going to need a value to encode here. So I'm just going to call it val, make it an I32, make it 0. And we're going to say, not I32. Why do I keep doing that? Val equals val, not val, encode, opcode. Oh, I can just do this and then pass in the opcode. And actually, we can just test this first before we go any further. Too few function. Oh yeah. So we need the opcode and the value. Aggregate value was used where an integer was expected. Yeah, see, I thought this might be a problem. So I think I have to call this as a function. It's a little bit unclear. Not a function or a function pointer. I'm not sure how to get the value out of the sum type without a match, right? So with a match, you get the value out. Oh, I have to pass. Does that mean I have to like call it in here? Opcode. No, doesn't make sense. I'm looking at this example again. I should be looking at the one in. Wait, what just happened? Okay. Out of range for the change set length. Something wrong with, I don't know, something to do with helix. All right. Whatever. And if we go into here, into the examples, into showcase, click. So we match on quit. That's cool, but we don't get the. See, this is just. I think this is the wrong structure again. What I mean by that is we're matching on the opcode. But we also need the opcode value. I don't know how to get it. So what does that give us? Expected opcode, but it's an int. Yeah. Is there a way to unwrap this or something? I don't see this stuff anywhere. Unwrap somewhere. Unwrap. Nope. All right, I got a bit of a headache. 1 second. Also, I need to pee, and I'm wearing headphones and my hat, but nothing's playing, and I'm inside. It could be why I'm getting a headache. Okay, I'm just gonna do a refresh here and see how this is going. Is it still trending? Oh, it doesn't say the stars. There we go. 908. Nice. Cool. Okay. It feels fine. So yeah, it was shape. This is just incorrect. Unless this somehow works just for this example. I think this is not actually right. Well, at least it didn't work for me. The destructuring. Syntax was different. I don't need any of that stuff. Now. Alright. So I'm passing in an opcode, which is an opcode. How do I get type out of it? Because it would be really dumb if I had to type, you know, match opcode and then something like this. There's no value here. What about like that? That doesn't make sense. Yeah, doesn't like that. Well, there's no V, so how do I get the value out of here? Is it dot tag? It is apparently dot tag. Not sure if that's the intended way to do it. So I'm going to look at the generated code. And have a look. Okay. So opcode.tag. It does refer to this value, which is the enum. So yeah, dot tag works. I don't know if that's what you're supposed to do, but that's how you can get it back as a number. So if that's correct, then we encode the opcode. And the first instruction is move immediate. Then we should have a 1 in there. So let's have a look. Where do we break? Yeah, that should be... Okay, that value is... Oh, that value might be correct. How do I print it as binary again? I'm pretty sure there's a way. Print binary in GDB. I like how I just have Wall Street Bets advertised in my browser. Print /t. Okay. Yeah, that's correct. No, that's not correct. Oh wait, no, that might be correct. I'm not counting the zeros. I'm gonna set this set print nibbles on. Yeah, that's correct. That's what I was expect. No. Yeah. Wait. 8, 16, 24, and then 32. Yeah. Okay. Finally. Okay. So we have our first encoded opcode. Now the other ones should just work. Unless I made a mistake in the code, which is always possible. So we're going to encode source as inst.source. And then we're going to encode the destination. No, this is actually value. There is no source. Destination as inst.destination. I mean, the source is the immediate value. Okay. That's a little bit confusing calling this one val. So I'm going to rename this to, can't call it instruction. I'll just call it X, I guess. So I can hold that one in my head. X is the binary representation of the instruction that we're building. For add register, we have a source and a destination. For alt, we don't need to do anything because it's already got the opcode encoded up here. Invalid, we also don't need to do anything. And something was not found. Tag, since I know how to print the tags now, I can print inst.opcode.tag. Oh. Typo. And another typo. Okay. No, I should have added... I guess I should have added something here to stop the program. Oh yeah, run, no. Okay, here we are. Got the bytecode. It's currently void pointer, but I'm going to cast it to U32. That's not a thing. I'll just make it symbol U32 is not a thing. uint32 underscore t. There we go. Okay, so the bytecode is empty. That's not good. I probably forgot to add it, didn't I? Yeah, all we did was update this x value and then we didn't add it to the bytecode. So what we do here is we say bytecode I equal to x. Alex says, thank you for your tutorial on 2D Game Engine in C. It's helping me a lot to learn how to use OpenGL. You're welcome. I hope you enjoy it. You're referencing void pointer. Oh. Invalid use of void expression. Oh yeah, because this is a void type. I'm going to cast it to U32. Okay. Nice. Print /t. All right, so that's our first instruction. What was that? It was like print nibbles on or something. Set print nibbles on. Okay, so there's supposed to be 4 zeros before this, but that's fine. Then we got our move. Then what was the instruction? What was the order again? Destination, source, and immediate. So destination is 0. So I probably put the destination as R0. Shouldn't do that. I should always put the destination as like 2 or 3 or something so you can easily see it. And then the value is this 0111 1011, which is 123. Yeah, that's an odd number. Because the last bit is set, so I think that's right. 2, 3, yeah. Should be. It looks right. I'm not like a super whiz at binary in my head, but it looks accurate. So what was I just saying? Something was, oh yeah, R0. So I'm going to change this to R2 and this one to R2. That way we don't have any 0 values because that can be confusing. Set print nibbles on print /t. Bytecode. All right, there we go. So this is the destination. Register 2. This is the value and the source. I don't know why I did it in that order now that I think about it. No, I didn't. The destination should be next to the opcode. Yeah, I did this in the wrong order. This should be 8. Oops. This should be 16. There we go. And I'll just swap the positions just to make it a bit nicer. All right, one more time. That looks better. So 2, 0, 123, and 1 is the opcode. All right, so now we've got our first instruction encoded into binary. We're almost ready for our virtual machine to use it. What other instructions do we have? Move immediate, add register. Yeah, so I guess no, I should have just checked the other ones right there and then. Bear with me for a second. Let's just do this again. Set print nibbles on. At least I'm never going to forget that command now. Probably. Bytecode +1. So that's the next one. The value 100, yeah. And the next one is... Hang on, that looks wrong. Is that wrong? Add register. Yes. Good thing I checked. Oh no, I did +1 again. I meant +2. Wait. Oh no, I'm stupid. I need to put that in parentheses. There we go. Okay. There we go. That looks okay. Add, what number is add? Oh yeah, it's like 0, 1, 2, 3, 4. Yeah. Yep, good. That looks good. And then this should be halt. Yep. All right, so the bytecode looks good. Now we can write the, I guess, the interpreter for the bytecode. So we're going to write a little bytecode interpreter here. It's going to just do, I guess we'll put it in the VM. So we've got the initialize, and then we do the run. suppose we just do run for now. I'm also going to do load program, I suppose. Yeah, we'll use this weird style. Bytecode is a pointer to a U32 array. And we're going to say that that memory is managed by the caller. So this is just going to be a pointer, I guess. And we're just going to blast through it, but we don't know how big it is if it's just a pointer, so I guess... I don't know if there's a way in Zen-C to make this a fat pointer where you get the length and you can use like a slice or something, but that's fine. We'll just pass in the length right now. I think there's a usize type. No, I'm just going to use U64. Alright, not U8. Although I guess that would fit. So we're going to load the program, and then we're going to run. So run is going to just run from wherever the program counter is, I guess. So it would be a while self.pc is less than self.byte code underscore length. Now we want to do something, but I really need to pee, so I'll be right back. Okay, I also got a little snack. Little protein yogurt thing. Doesn't come in tubs for some reason, so it's like eating baby food. All right. So where were we? Okay. We got, hopefully, a little virtual machine running. That's incorrectly spelled. And now all we've got to do is blast through these instructions. So we're going to match again on the... No, we're not going to match. We're going to get the opcode. We need to decode it first. So yeah, so I'm going to say instruction actually is decode. We're going to decode the bytecode at this position. So self.bytecode, self.pc, set the program counter, get the bytecode, which is going to be U32, decode it into an instruction. So now we have to write a decode function. I wonder if we can write that down here, or if it's going to complain about the order of things. So we're just going to decode a U32, probably not call it instruction, I'll just call it X again. And we're going to return an instruction. And now, what are we doing here? So, instruction. Actually, I could just do equals. And we need to decode the values in there. So if there's an opcode, I guess we just do this. Go to opcode, pass in the value here, change these to destination. Source. And val. So just always do it regardless of what kind of instruction it is, and then just return that. Not decide, but decode, destination. Destination is a U8. I think we got rid of the... Oh, we didn't get rid of registers. So destination is actually a register. I guess we can refer to it as such, right? No, wait. What type does instruction hold again? Register. Okay, yeah. Cool. Yeah. So this should be a register. So we're going to say... It's just the inverse of these encoding instructions. So shift down by 16 bits, mask it off. And then that will give us the opcode, which we can hopefully cast to... Not the opcode, but the destination. Maybe we should do the opcode first. Why do I keep not doing that? Opcode first. So we're going to say X shifted down by 24. I guess I'll call it res or something. Or opcode. No. I don't know why I care about the name. It doesn't matter. It's just a tiny function. Now I'm going to say v equals... I could just do this on this line, actually. Shift it down by 24. Mask off the last 8 bits. Mask off the other bits. Or mask on the 8 bits? I don't know. You know what I mean. We only want to keep the bottom 8 bits. Right, now we've got our opcode, and we can say return opcode, hopefully, v. I don't know if that's going to work. So I guess we should try that first before we do this. All right, what have we got? X is undeclared. It isn't. but okay. Implicit declaration of function decode opcode. Did you mean encode opcode? Yeah, I need a function keyword here. Okay. Conversion to non-scalar type requested. Yeah. I thought that might be a bit of a problem, so I might need to do some shenanigans like tag equals v, and then that should work. Unexpected token dot. Oh yeah, different language. Expected expression before opcode. What? This is in the generated code. Let's have a look. Yeah, right. Okay. Zen tip. Yeah, I know about XOR swap algorithm. Okay. These tips have nothing to do with what I'm doing, pretty much at all every time. So that's interesting. I don't know if it's just supposed to be like for fun or something, but it's pointing to a place in the code where I'm not trying to do a swap. Okay, I need to test this. Code, opcode, yada, yada, yada. I'm just going to put a break here. By the way, this only works on certain compilers like GCC and Clang. If you want to do a break on Windows, if you're using MSVC, then you'd type underscore underscore debug break, like that. So you could just define a macro as well, and then depending on which platform you're using, use a different method. Okay, inferior process exited normally. I love Windows, not Windows, Linux speak. I don't know what it's talking about. Why is it inferior? We haven't called decode anywhere, so that's really the problem here. So what I'm going to do is I'm going to grab this instruction. I'm just going to try to decode it. What's wrong with this? I needed to pass in 32, but I passed in... sorry, you went 32, but I passed in instruction. Oh, yeah. Right. Yeah, what am I doing? I need the bytecode, not instruction. Okay. Oh. No, why did I stop? There we go. Okay, there we go. So... So I've got the instruction here. It's a move immediate. Destination is R0. That's wrong because I didn't do that yet. But we've got a move immediate. Okay. That's good. That's working so far. Great. Okay. So this is how we can coerce a number into an enum. It's a bit not what I'm used to. I'm used to casting. But anyway, that's fine. Now let's make these functions. So rather than opcode, actually, yeah, rather than opcode, we're going to do destination, and that's going to be a register. Register, and this is going to be 16, right? Yeah. Cool, and then source is going to be 8, and then decode value is just x and 0 except for, yeah, that should be fine. Okay, let's see if that works. No. Oh yeah, doesn't return a register, it returns U8. Okay. Register UN8 was expected. Oh yeah. So I just need to return a U8, which is this. Okay, here we go. Run. Okay, we've got move immediate. Destination is R2. Source is R0, but that's just because it's a 0. Because 0 is a valid register. Maybe I should make invalid the first register, so that would say invalid, register invalid tag. But then if you wanted to compress the bits, you would be losing 1 bit. Doesn't really matter for this toy example though. Value is 1, 2, 3. Okay, cool. Great. There's some yummy protein yogurt. It's really thick. It's only like 88 calories, 15 grams of protein. It's pretty good. And it tastes like strawberries. Salty strawberries, which is a bit strange. Alright, so decode. This wouldn't be in here. It would actually be in our run function up here. There we go. Oh, I've already got it. Cool. So we've got our instruction. Now we can match the instruction opcode yet again. And I'm just going to grab this so I don't get it wrong for 30 minutes. Alright, so invalid, we don't have to do anything. I wonder if you have to cover all cases, if there's exhaustive case matching. Don't think so, because I didn't do all cases here. And it didn't warn me either. That might be something to look into. Okay, so we're going to move into immediate. And now we have to actually do something. So we know what the instruction is, we can do something. So we got self, which is a VM. Let's just get the type up on the other side over here. The VM has some registers. So we're going to say registers. Now we need the index, which is going to be instruction.destination, which is a register. How do I get it again? .tag, I guess. Equals instruction.value, which is just a U8. So is that going to compile? Apparently. Undefined variable inst, did you mean inst? Tell me about swapping again. So inst is here. Inst should be defined here. I'm just going to run it without GDB for a second. No, I'm not actually. I want to look at the value in the register after we run, but I didn't call run. So let's do this. VM.run. And I'm just going to put a break here. ASM. Wait, what? Okay. Did I not set the bytecode length? Oh, I didn't actually fill out the load program. I did, but I didn't call it. So we have to load the program. I'm just going to say that it's 8, even though it's not. Okay, run. Okay, here we go. So it would have just gone through the loop. I'm out the other side, and now the register should have changed, right? Because we moved a value into it. So if we print self dot registers 0, it's 0. It's not register 0, is it? It's register 2. Hey, would you look at that? In register 2, the value 1, 2, 3. Perfect. All right. That's cool. So now I guess what I'm going to do here is I'm going to say print, I don't know, print registers or something. And I'm going to also print opcode. I'll fill this in a second. Or print instruction. And registers of, I guess I could do self.print registers. I'm going to print 0 is this value, which is going to be self.registers 0. Whoops. Hello, I'm pressing the wrong buttons. I have two keyboards. One is QWERTY and one is Colmac, and one is split keyboard and one is not. And just because I switch computers a lot, so my typing is just not as good as it could be. Okay, I don't know how long I've been streaming for, but oh wow, almost 3 hours. Okay, I gotta finish this up. Get this little VM running. I am running out of steam here. Print instruction. Okay. Print instruction. The temptation, if you're using a language that has methods, is to do something like instruction dot print, and then this could be like print registers. That's fine. And now my instruction would have an implementation. And a function, which would be print, and then the print would do whatever. And I guess all I want to do here is I want to print X. No, that's hex. That's hexadecimal. How do you print binary again? Can you even do that? I don't think you can do that in C. Let me look it up. Print binary in C. Also, you have to actually write a macro byte to binary. Yeah, okay, that'll be fine. I'll just use that. Oh, I can't paste here. Oh, there we go. Okay, so that's just 1 byte to binary. Fine. Thank you, Stack Overflow. Still giving us the goods even after your death. So when we print the instruction, we're going to say, what does this give us back? It gives us a pattern, and then, okay, so this would just be, okay, each byte. Okay, I got it. I got no autocomplete. Byte to binary pattern. Byte to binary, and that's going to be I guess self dot, yeah, opcode dot tag. I think that will work. I'm just going to try this first. See if that works. Print registers. Probably messed up something. Let's see. Oh, okay, it's working. Cool. Oh yeah. So if we get to a halt, we want to... Wait, why is this still running? Oh, I didn't increment the program counter. Whoops. Not the encoding, but the run. What just happened? Run. Here it is. Increment program counter. What? Okay, I must have just modified something. Oh, I changed that to a U. Nice. Cool. So it just does 8 instructions because it thinks that 8 is how many there are, which I guess that's technically true. Or actually true, not even technically. But we can do here, opcode halts. And then we can do break. Wait, what was that? How did you break out of the loop? Break outer. Yeah. Like this. Does it have to be in parentheses? Maybe. Don't know. So, do these labels work yet? Let's see. Does it have to be loop? Maybe it has to be loop. This thing stopped working again. I don't understand. I get maybe irrationally upset when things don't work. There we go. All right. If done, break out of loop. So this doesn't work. Okay. Unless... No. Outer loop. Outer loop. All right. That's fine. We can... And not done. So done is false. Done is true. That should work. What's wrong with this? Cannot assign to const. Wait, what? Why is it constant? Okay. Is that going to make it constant? No. Okay, interesting. So booleans are becoming constants for some reason. Which doesn't really make sense for most uses of boolean. Because they're supposed to be toggled. Anyway. Now we're only running the instructions that we wanted. Which is move, add, and what is this? Halt. Yeah, move, add, halt. I need to fix the printing. Where is it? This. Let's print a new line. So that's just the opcode, which I guess that's enough to understand what's happening. So I should have just called it I can just print the other bytes. Let's just print the other bytes. Okay, so we got byte, byte, byte. And it's, I keep forgetting the order. Destination, source, immediate, no tag. Then we're going to print space in between. And that should give us the full thing. And what? Something wrong with this? Instruction. Oh, it's not called immediate. I called it value for some reason. Usually call it immediate. Anyway. Cool. So move, add, which doesn't add yet because we didn't actually fill that out. So we're so close to this working. So if we go here, we go self.registers destination equals, I'm just going to call it v, and I'm going to say v is self.registers inst.test.tag plus there we go. Now, of course, if you pass in garbage to these, to the bytecode here, you're going to get an out of bounds lookup on the register array, which you might want to check or not. I just say that if you feed invalid bytecode, then you get like crashes. That's my philosophy about that. So just make sure the bytecode's not invalid, because otherwise, you know, you're all the way sort of down the chain of building the program at that point where you've emitted bytecode. It should be valid bytecode. Checks should happen, I think, much closer to the surface level, but maybe some other people disagree. Anyway, there we go. Move, add, and now we have the value 223, which is 123 plus 100 in our register, and then we halt. So I would say that is a success. I would say there are definitely some warts right now with Zen-C. It was not Zen for me anyway, not yet. So we'll see what happens with this language. It's very new. I think it's got potential. I think some things are a little bit weird, or maybe I just don't understand the programming style, like, you know, accessing enum tags like this, or what else was there? It's mostly enums that I struggled with, to be honest. Pattern matching is kind of interesting. We could get some more use out of that, I think. Also, having to call this as a function is a bit weird. Yeah. Oh, yeah, also a bunch of the stuff in the docs just isn't in the language, like breaking out of loops, and this print doesn't seem to exist, or I have to link something, I'm not sure. But all in all, I like it. I think it's got some potential. So let me know what you guys think in the comments, or in the chat if you're here right now. Yeah, I think that's going to be it. I think that's a good time to end the stream. We built a little virtual machine. You know, it's only 200 lines of code. It's a little register version, little register virtual machine. Let's see, what have I got here? Oh yeah, is this? Can I look at this? All right, so the reason that I know how to build a virtual machine from memory is because I've been working on this game, which is going to come out. It says 31st of December. That's wrong. This Steam page isn't up yet. I think it's going to be approved in the next couple of days. And this game is a programming game where you program a little quad-core microprocessor. Of course, it's a little virtual machine. And there's sort of a narrative going on in the background. So you get these emails from people as you're doing jobs, and things are sort of getting kind of crazy. But your job is basically like fixing infrastructure in this 1990s megacity in alternate history. So this is going to come out, I think, 31st of July. is what I've set in Steam, although this says 31st of December for some reason. Whoops. The playtest, this playtest has been approved actually. It's gonna come out hopefully tomorrow or the next day. I just need to get the store page approved for the regular app because it's not showing up in Steam yet. But yeah, I'd love it if any of you guys are interested in this kind of game, like sort of like a Zachtronics puzzle programming kind of game. Check it out, see if it's for you. Just assembly programming basically. And yeah, so this is the UI, sort of the old UI. I also built a new UI, which I'm still in the process of making. Let's see if I can find it here. So I'm just looking it up on my profile. Here we go. Okay, so new UI looks like more like this. I think I'm gonna modify it a bit. I think this is more sellable on Steam. Like it looks like a more effortful game, but this one is clearer. I think with what's going on, so it's kind of a trade-off, and also the vibe is a bit different. So I'm gonna try to make the vibe match a little bit more. But yeah, anyway, that's what I'm working on apart from the program video game stuff. And yeah, I want to thank you guys for tuning in, and I hope to see you soon for some more programming. So catch you later.